over the weekend, you should see that the grades were already posted for the quiz. I'll give them back at some point this week, probably tomorrow. Looking at tomorrow. So what I explained to you last week, I'm going to give you a packet. This one is thicker, but we also have more time to cover it. If you guys can, be proactive and participate and actively listen and stuff, and we can finish this in 4 days, then Friday can be used to work on this week's assignment, which is also on Khan Academy. The grades for last week's homework are in. You'll see them by tomorrow, but they weren't all that great. If we need to take all 5 days, then we take all 5 days. We should be able to get this finished in 5 days. Any questions? So the difference between this week and last week is this has to do more with data displays, how to display data. So we took some measurements with data. We took, mean, median, mode, and range, and interquartile range, and all that stuff. But we only really did one data display. What was the data display that we dealt with last week? Where it's a graphical display showing the data that we had collected. The box and whisker, yeah, you've been exposed already to a box and whisker plot. Well, now this week we're going to learn a variety more. So I'll try to go through these first pages pretty quickly so as to try to not lose your attention. But see, okay, the first one, a two-way table. This is the one I probably have the most information on, but we won't get to this until probably at least Wednesday. If we can get to it sooner, great. But what a two-way table is pretty self-explanatory. It has information going in two directions. It's made up of rows and columns. Okay, so what I like about this graphic is it takes something that maybe you are used to. What is that called? You've never seen that before? With two circles that overlap? A Venn diagram, yeah. So most of you should be able to read a Venn diagram. So this is this data relates to students that are taking classes and participating in a sport. So right here, these 23 students, okay, they are in a foreign language, but they do not play a sport in this school. These 10 students play a sport but do not take a foreign language class. What's true about these 14 people in the middle? Yeah, they do both. And then here on the outside, there's 3 that do none. This same information can be expressed in a two-way table where you have two axes. Okay, so it looks like here we have on the left side, we have whether or not they take a foreign language. And then along the top, we have whether or not they play a sport. Okay, so wherever they intersect, so like somebody who plays a sport and takes a foreign language, which we saw when there were 14 of them, that would go there. If you don't play a sport but then take a foreign language, there's 23 that goes there. So that we can refer to these, so when you see these words later, you know what they mean. Those are called the joint frequencies. Wherever a column intersects a row, wherever I put it, the entries that are in the body of the table, those are going to be called the joint frequencies. Okay. The marginal frequencies. Those are the totals at the end. So I don't know if this makes it harder to read. Normally you won't see this, so maybe if you want to scratch it out, you could. Like this first part. This is meant to explain, so I think that's why they put this extra information here. But see, like at the end of foreign language, you see a 37. What does that mean? Well, in total, there's 37 students out of this sample that are taking a foreign language. How many don't take a foreign language? If you add 10 plus 3, that gives you 13. So these totals at the end, those are called the marginal frequencies. Totals that are in the margins. Okay, now this is where like we're probably gonna spend an entire day on this, and this is what it's not that it's hard, but this is what requires the most interpretation. Let's say you wanted to turn that information into a percentage or a probability. Okay, well, a relative frequency would get really the maybe write it this way: the marginal frequency divided by the total. So if as long as we're talking, how many students in total were part of this sample? Yeah, there was 50 kids, right? So if I were to say, hey, what percentage of that 50 did not take a foreign language? Well, how many kids did not take a foreign language in total? 13. You do 13 divided by 50, that will give you 26. That's 26%. Okay, that's called relative frequency. Okay, the last one, conditional relative frequency, would be, and these are just names. It's not like you don't really need to know the names in order to be able to get these right. But conditional relative frequencies, when you do the exact same thing, but now you're doing the joint divided by the margins. Here's an example. Again, how many people were there in total? There was 50 in total, right? But now let's say the wording says, of the people that play a sport, how many took a foreign language? Well, by starting off saying of the people that play a sport, we're not looking at the entire 50 anymore. We're only specifically focusing on people that play the sport. How many people play the sport? 24. And of that 24, how many also took a foreign language? 14. So when you would divide, it's still division, but when you would divide, you'd be dividing the joint by the margin. Relative frequency, it's marginal versus total, but actually, you know what? It actually could also be, it could be joint also. So you could either do the joint or the marginal, but the fact is that you're dividing by the total amount. Conditional relative is when you're dividing by the marginal frequency. And it seems confusing, fine. Let it stay confusing for a couple of days. Once we get to two-way tables, it'll make more sense. Histograms. These we'll start getting into today a little bit. So here's just an example of histograms, right? The age at inauguration of U.S. presidents. So here's a table that tells me that when they were inaugurated, there were 2 different presidents that were between 40 and 44 years old. There were 7 that were between 45 and 49. 13 were between 50 and 54, so on and so forth, right? So that same data can be displayed by using a histogram, or what you guys call a bar graph. You might have called that before, because what it does is it measures the frequency as a bar. The higher the bar goes, the more that there are. So this first bar measures from 40 to 44. How high does that bar go? How high does that bar go? 2, yeah. Yeah, it goes 2 units high. The next one is presidents from 45 to 49. How high does that bar go? Yeah, 7, sure. And so on and so forth. The higher it goes, where these heights, the heights of the bars, are supposed to measure the frequency of how many presidents were in each range of ages. Now, one thing that I do not have I just don't have like a graphic for. They're gonna show up. I don't have a graphic for, but it's very similar to histogram. Is a dot plot. Okay, so when you start seeing dot plots are kind of like histograms, but then the only thing is instead of bars, they use dots. So like, how many presidents were between 40 and 44 when they took office? 2. So what they would do is, like, you wouldn't even need that. You would just put like 2 dots going up. You'll see some of those. How many presidents were between 45 and 49? 7. So you would see, 1, 2, 3, 4, 5, 6, 7 dots going up like that. It's very similar to a histogram. You'll see some of those. Once we start getting into these dot plots or histograms, we can start to study the shape of a distribution. Luckily, I hope that I saved us some time because I started kind of talking to you about this last week. I told you to expect this week, the different shapes of distributions. Okay? If you trace the tops of either the dots or the bars, that's what gives you the shape, right? What characteristic of the shape is probably the most important thing to look at? You remember? The tail, very good. We talked about the tail. So, and a negatively skewed distribution, okay, what appears to be the tail of like the little mouse is on the left. On a positively skewed distribution, the tail is on the right. If there really is no tail, what was called a two-tail, then this would be a symmetric distribution. It would have the same amount of tail on both sides. This is just a very quick way to look at data without having to be too analytical and try to study it. What I tried to teach you last week quickly, because we got into this because we were talking about mean and median. The mean is always going to follow the tail. Whatever side the tail on, if you're comparing mean and median, the mean is always going to be closer to where the tail is. If you have a symmetric distribution, then the mean and median are pretty much the same. It's all approximate. They don't have to be exactly the same, but it's approximate. One other type of distribution that we'll eventually get into is a uniform one. I didn't have a better graphic of it, but if you were to trace a uniform distribution, it's just right across like that. Don't get uniform symmetric. So like meaning all the bars, if these were all bars would be, at the same height straight across. If every single one of these president things was like, for instance, 3 presidents were this whole, 3 presidents, 3 presidents, 3 presidents, 3 presidents, 3 presidents. How would that look like as a distribution? It would be uniform. The tops of the bars would be the same all the way across. Any questions there? I'm just trying to get through this quick so we can get to the examples. Okay, a line graph. A line graph is somewhat similar to a histogram, where there's 2 axes. Okay, just like a histogram had 2 axes. Look, there's going up was number of presidents. Going horizontal was age at inauguration. On a line graph, we're also going to have 2. This one is months. Okay, months, and then dollars in sales. But now, instead of shading a bar to go high, wherever the intersection is, you put a dot. Put a dot. So there's a dot for September, a dot for October for the sales, November sales, December sales, January sales, and then all you do is just connect the dots. That would be a line graph. I don't. From the examples I've seen, I didn't see too many of these. But it's there. Stem and leaf plot. This is one that you will see. How many total numbers are there? Please don't tell me you're counting. How many numbers are there? 20, right? So if you wanted to express these 20 numbers here in the stem and leaf plot, these are all 2-digit numbers. So what you can do is the stem here is just the first digit of all those numbers. Then the leaf would be all of the second digits. How many 32s are there? 2. So if you see like 32 and 32, that's why next to the 30, there's 2 2s. How many 35s are there? 3. 35, 35, 35. That's why you see 3 5s. That counts as 35, 35, 35. How many, here, let's see if we can read this quick. How many 45s are there on this graph? Yeah, or on this table. 2, yeah, there's 45, and let's see if we can find them. 45 and 45. That's called a stem and leaf plot. And the last one that we'll go over, but you're really not going to see it too much, but just to give you free information, a circle graph. What a circle graph does a good job doing is showing percentages, because we consider the circle to be one whole, and then we just want to break up the circle into pieces according to what makes up a whole. So this is if, like, for instance, if you were measuring this in percentages, you know, how many percents make up a whole? How many percents make up a whole? 100, yeah. But this particular one's not being measured in percentages; it's being measured in hours. So this is just breaking it up. Hey, how many total hours were spent doing activities? 8. So out of that 8, okay, 2 is a quarter. It's 25% of 8, so it takes a quarter of the pie. Same thing with over here eating. The canoeing takes 3 hours, so that's 3/8 of the pie. It's just a way of being able to graphically display information. Okay. So let's start going into then the examples. When I was looking over this again, I think okay, I might have made a mistake. There's so much of these little worksheets that are in the shared drive for the teachers. Maybe I made a mistake ordering these, but I think it's better left as review. I would rather leave this first page and even the second page till the end of the week. So let's actually start off then on the third page. Let's start off here, where it says graphical displays for data homework. And we'll come back to the first two if and when we have time. Example 1, a pharmacy records the number of customers each hour that the pharmacy is open. The staff is using the information to determine how many people need to be working at the pharmacy each time of the day. The number of customers in the table, the number of customers is in the table below. Use the table to create a histogram. Okay, so we want a bar graph here. Not because you have to, because it says you have to, but what do you think is more important? Of the two things that, like, there's two columns here, right? One is measuring time and one is measuring people. What do you think this particular histogram is going to be intended to measure? What would be the most important of the two measurements? Okay, better yet, let me not use a word like important. Let's think about words that we already know. Independent and dependent variables. You've heard that before. Okay, X is independent, Y is dependent. So when we think about this here, does the number of customers that are in the store depend on what time it is? Or does the time depend on how many customers are in the store? All customers depends on time. If people stop showing up, doesn't mean time is going to stop. Time is going to keep on going. Time will continue independently of how many people are in the store. But then depending on what time it is, that, you know, different stores have their busy hours, their less busy hours. So not because you have to. I've seen bar graphs go sideways, but typically, normally your independent variable should be like your X horizontal, and then your dependent variable should be the Y. So in this case, I'm going to make time the X. I'm going to make that horizontal, and then I'm going to make the number of customers be the vertical. We need to go from 8 to 5, right? So 8, 9, 10, 11, 12, 1, 5. What do you think will be a good scale to use on the way up? I'm not going to write every number from 0 to 23. What will be a good scale to count by anything on the way up? 5, maybe? You want to count by 5? Let's put it at the tippy top here. This will be 0 down here. This is time. And then this is over here. This is customers. If I had space, I would write it just going down. The number of customers. Number of customers. So let's say like this is 5, 10, 15. I'm running out of space, so I'll go a little higher. Grab a packet. So from I'll worry about the shading part afterwards. Let's just draw the tops of the bars. How high should my bar go from 8 to 9 o'clock? And between 8 and 9, how high should it go? 2. So 2 should be roughly like around there. Okay. How high should it go between 9 and 10? 0. So I shouldn't have anything between 9 and 10. I should say empty. How high should it go between 10 and 11? Up to 8. So that's going to be like sketch. How about from 11 to 12? 14, so things are picking up at that time. Like here. All right. How about from 12 to 1? 23, that is the highest one. So this bar is going to go way up. Like and then from 1 to 2, up to 12. So that's going to be in between the 10 and the 15, a little bit closer to 10. Doesn't have to be perfect, just not way off. All right. From 2 to 3, down to 7. Which did we have a 7 earlier? No, we had an 8 earlier, so this should be a little bit lower than 8. From 3 to 4, we're back down to 3. Be a little bit higher than the 2 that we had at the beginning. Wow, my scale's way up. At 3 almost looks like a 7. And then finally, between 4 and 5, we got up to 5. This would be easier if I had like a grid. They're not asking us to do anything with this, but that'd be roughly what it would look like. Any questions for me? Which bar graph thing looks better, Jason? Yours or mine? I guess you could also shade these in, but you don't have to. Are you asking questions, Anna, or is she asking questions?
Is that negative?
Is what a negative? What be negative?
2.
Oh, yeah. What type of tail? It would be hard to I'd say probably be closer to 2 tail. I mean, there is this gap here, but if I were to trace the top, that seems somewhat symmetric. It doesn't like the way that you would tell to be sure is take the mean and median. Here are your numbers. Figure out what the mean of that is and figure out what the median is. If the mean and median are roughly the same, it's probably symmetrical. If you see that the mean and median are way off, then whatever side the mean is on, it's either right skewed or left. But it looks just off the eyeball, it looks closer to symmetric. It's not perfectly symmetric, but it looks closer to symmetric than to skewed. Anna and Ethan watch 10 30-minute shows. During the month of June, they record the number of food commercials that air during each show on the table below. Create a dot plot with the number of food commercials that aired in the 10 shows. So which one do you think here is going to be the independent and which is going to be the dependent? Does the number of commercials depend on the show, or does the show depend on the number of commercials? Yeah, number of commercials depends on the show. I mean, if you're ever not sure, think about it. What am I trying to study? I'm not trying to study the show. I'm trying to study the commercials. So on a bar graph, you probably want that to go up. That's the part that's going up and down. So on the bottom, we have shows. So down here is the show, and then here is the commercials. Up to J. So A, B, J. And then, well, it's not too bad. That should be the top at 10, so the middle at 5, 0. The first one's at 7, so 7's in between 5 and 10, a little bit closer to 5. The second one is also 7. The next one. The next one's at 5. So that'll be like right around there. Then the next one is at 7. That. 4, which is a little bit below 5. Then 7 again. Definitely looks like 7 is going to be the mode here. Then 5. Then 9. So this one's going to be the highest. Then 5. And somehow 6. The shape there, I mean, maybe uniform, I guess. I don't know. Any questions? Kiara, you okay? Does it smell like pine sol? Ray's scores on his math test were like, oh, look, draw a box plot. I'm more inclined to skip this. Does anybody feel that they need more work with box plots after last week? I'd rather just do this. You want more work with box plots, Sam? Okay. I mean, I want to review it at the end of the week, but remember, a box plot is all about median. So we need to put these in order and figure out what's the median. Are these in order already? No, they're not. So we have to put them in order. 70, 82, 83. Sam, did you try doing your assignment? 78. I skipped the 78. Oh, it's awesome. Did you do your assignment on con, Sam? Did anybody find the assignment to be helpful from last week? Did you do the assignment on Khan Academy? I think I like how it's interactive. 85 and 90. Nakai, you're the data police. Did I get everything there? How many are there? 7. So let's get my quartiles. Q1. Q2, Q3, a min also and a max. So what's the minimum here? 70. What's Q1? Oh, I guess we put that already. Out of 7, the median is going to be 83 because that's the one in the middle. That's Q2. Then how many are, when there's an odd amount, you do not count the one in the middle. How many are left on each side? 3, which is also an odd number. So that's going to be your Q1 and Q3. So Q1 is going to be 78, Q3 is going to be 85, my max is 90. Let's do the first question. Sam, what's the interquartile range? IQR, what is the interquartile range here? Samantha, no? Interquartile range? Do you know how I found these numbers? Do you know how I found? Okay, so interquartile range is always going to be Q3 minus Q1. What is 85 minus 78? Okay, thank you, Bree. It's 7. So are there any outliers? The way you would check for outliers is multiply that 7 by 1.5. 7 times 1.5, it should be 10.5. So I want to see, do any of these numbers fall either 10.5 below Q1 or 10.5 greater than Q3? And if so, they would be outliers. 78 minus 10.5 is 67.5. And then 85 plus 10.5 is 95.5. So are there any numbers that are either above 95.5 or below 67.5? Do any numbers fall in the outlier range? No. So I don't have any outliers. That means on the box and whisker plot, I can extend my whiskers all the way to the end. So let's start at 70. Let's go by 5, so 75, 80, 85. This is my least favorite one to do freehand. So once we have that, now we can do our box. Where are the edges of the box going to be? First the box and then the whiskers. Where are the edges of the box going to be? No, the edges of the box. Box. 85 would be 1, yeah, and 78. That's where your quartiles are. 78, 5, box 0. Whereas the median is going to be at 83, so the median is going to be somewhere like this. And then the max and the min are the middle whiskers. The whiskers. The minimum is at 70 all the way out here. And the max is at 90. I may have not drawn this perfect because this was freehand. Let's buff it out. Any questions there? We'll do more of these before the week's over. Just draw a box plot. You guys want me to do another one of that? Because I'm trying to get to everything. Do you want me to just do another box plot now? This one's going to be longer. You're going to have to calculate the median with this. Are we okay with box plots for now? We'll come back to it. Another box plot. All right, so then let's just keep on moving. Just put like a little star by that page, and if we have time at the end, we can come back to it. All right, perfect. Here's a good one. So these are for dot plots. We talked about dot plots already. So males, females. So 30 female users and 25 male users were selected at random from a database of people who play a video game regularly. Each of them agreed to be part of a research study and report their scores. A leadership score is based on a player's answers to leadership questions. A score of 1 to 40 is considered a beginning level leadership score, and a score of 41 to 60 is considered middle level, and a score that's greater than 60 is considered advanced. Use the following data to make a dot plot of the female scores, a dot plot of the male scores, and a dot plot for the scores of the combined group of males and females. Okay? So we got to see the frequency. We got to see how many of each. Yes, thank you. Uh, how many tens are there for the females? How many tens is one? So I'm gonna put one dot. How many 20s are there for the females? 3. So I'm gonna put 3 dots. How many 30s are there for the females? Also 3. So I'm gonna put 3 dots going up. How many 40s are there for the females? Also 3. So I'm gonna put 3 dots going up. How many 50s are there? There are 2 50s. But now there's also a 55. So in between the 50 and the 60, I'll put a dot. How many 65s are there? 4. So in the middle here, 1, 2, 3, 4. Then 70s. How many 70s? Also 4. 1, 2, 3, 4. There's no 75s, but 76 is pretty close to 75. How many 76s are there? Is there 8 of them? Okay, so 1, 2, 3, 4, 5, 6, 7. Nakai's not here right now, but he was asking about distributions. I mean, you never know until you check it for sure. But what type of distribution does this appear to be? Yeah, negative, or it's called skew to left. Skew to the left. The tail seems to be somewhere on the other left. Dan, you follow me or no? Okay, so now let's go to the males. How many 15s? 1. There's no 10, it's 15. How many 20s? 2. How many 25s? 4. So 1, 2, 3, 4. How many 30s? I'm counting 5. Well, you're right, 6. Wait, how many 35s? 5? 1, 2, 3, 5. 3 40s. 1, 2, 3. Definitely, they weren't as high. They're more bunched up. When it's spread. 45s are going to be 3 of them. And then there's 1. This appears to be a more symmetric distribution. Then at the end, the leadership just means add them all up. But since we've already done dots we don't have to go back and look at the table. I would just count dots. How many total 10s were there? 10 is 1. Then as far as to the 15s, there'd be 1 there. Then for the 20s, there's 2, 3, 4, 5. Then in the middle, there's 4. 1, 2, 4. For the 30s, it's 9. 35, there's 5 of them. 1, 2, 3, 4, 5, 40. How many 40s are there? 6. Good. 1, 2, 3, 4, 5, 6. 50. There's 3. I'm sorry, I skipped 45. Sorry, I skipped 45. There's 3 45s. There's 3 50s. 1 55. And then the rest is just going to be a copy of the 2. 1, 3, 4 65s, 4 70s, and then how many was it? 8 76s. This distribution seems to be kind of all over the place. Any questions there? Did I skip a page? Oh, no, sorry, yeah, this is the one I'm talking about. All right, so let's go this way. What do you think is a typical score for a female user? What do you think is a typical score for a male user? And explain how you determine these typical scores. Well, with the word typical, I equate the word typical to median. So if we understand the shapes of distributions, the mean is going to follow the tail more. So for the female one, the mean will probably be somewhere on the left side. Like, what would you estimate would probably be the median? Yeah, it could be. But there was what? There was 30 females. So the median would be the 15th and 16th scores. There's 8 and 8, 16. Yeah, so it'll be about 65 is a typical score for a female. So female would be 65. For a male, what appears to be, see, the male is more symmetrical, so the mean and median should be more closely bunched together. It appears the typical score is going to be what 30? And then why is it more difficult to report a typical score for the overall group? Because the shape is irregular. It's all over the place. If we trace the tops for the combined, first it goes up, and then it goes down, and then it goes up. Whereas the male was more symmetrical, and the female a little bit off, but for the most part it appears to be more skewed to the left. Tail appears to be. The following histogram represents an age distribution of the population in Kenya. What do you think this graph is telling us about the population in Kenya? Okay. Look at the shape of the graph. Interpret that. You know, 17% of people are between 0 and 5 years old. 15% is between 5 and 10. Let me ask you a better question. I know this says Kenya, but I would expect to see this type of shape anywhere you look at it. Because what tends to happen to people as they get older? Yeah, they die. They stop existing. So that's what this is telling me. What do you think this is telling us about the population of Kenya? As people get older, they die. They didn't really ask a specific question. Why might we want to study the data represented by this graph? I don't know, life expectancy maybe? See how old it would. Nakai, what type of skew is this? Yeah, positive, or you can say a right skew. Tail appears to be there. The mean, if you were to calculate the mean age, it'd probably be somewhere in this area, whereas the median is going to be somewhere around there. Based on your previous work with histograms, would you describe this histogram as representing a symmetrical or a skewed distribution? Well, we just answered that one. It would be skewed. And in what direction would it be skewed? To the right. Or if you say a positive skew, that's fine. What would be an explanation for that? What do you look at that determines if you're symmetrical or skewed? The tail, yeah. Sketch a histogram that is uniform. Okay. I did this for you on the first page. What does a uniform distribution look like? Yeah, they're all the same heights. The histogram would look like that. Something that's skewed left would be like the little ones would come first, and then it would get bigger. Skewed right would be the opposite. The big ones come first, and you get smaller and smaller. And then symmetrical would be digital and then big. And as you're getting the median and the mean are more or less. Kiara Jackson, how dare you? Let's see the next page, see how much time we have. Dot plots. And then find median and mode. All right, we'll do this one. We'll do example one, and then we'll call it a day after this one. So for a dot plot here, so let's start off with 3, 4, 5, 6, 7, 8. I don't need to really have axes. I just have dots. So how many? Oh man, there's a 2. Son of a gun. I didn't see the 2 there. There's a 2 stuck in at the end. How many 2s are there? 1. Another good idea would maybe to be to count the total so you don't miss any. So here I got first 5, second 5, and there's 15. So I'm gonna need 15 dots. How many 3s? Okay, 5 3s, 1, 2, 3, 4, 5. How many 4s? How many 5s? None. How many 6s? None. How many 7s? 3 7s, good enough. How many 8s? 4. And then you can check and see if you did it right. Let's see. Are there 15 dots? 7, 3, 6, 7, and 8 is 15. Yep, that's right. And then find the median and mode. Okay, well, the mode we know it's easy with the dot plot. What's the mode here? Yeah, 3, because 3 occurs the most. And the median, Sam, we'd have to get these in order. But it also helps to have a dot plot, because then I can just say there's a 2, or even better, watch. I'll save myself the time. There's 15 of them, right? So for 15, what number falls in the middle? The 8th. The 8th number is going to be in the middle of 15. If you have the 8th number, you'll have 7 on each side. So watch. 1. Oh. So 1, 2, 3, 4, 5, 6, 7, 8. What's the median? Add it up on 4. The median is 4, and the mode 3. We'll do example. We'll start off here with example 2, doing a histogram tomorrow. But really, the main thing tomorrow. Let me see how far away we are. This is what I have to get to tomorrow. Absolute deviation. Then Wednesday will be for the 2-way tables. Thursday would be a flex day, and then that way if we finish, we could do homework on Friday.